Okay, here we go. New lab on the plate. This lab is for static and kinetic friction testing. We're using the Palm Pilots again, so we want to go into the Data Pro program, and it'll show you what version we're loading. While it's doing that, I'll show you kind of the apparatus we're using. There you can see is a 2x4, which is hooked to a string, which is limp right now, and then it's hooked to a force sensor, which is then hooked to another string that Jordan will eventually end up pulling. Over here there are also some masses, and you'll add combinations of those masses. I think one of the trials has you do 200 grams, the other one has you do 400 grams, so you can then just tape those onto the top of your block. Now, here's what your calculator looks like, or your Palm Pilot. You again want to go through and zero it, so we're going to do setup, and 0, and that says select sensors, so you can just zero that. And it beeps at you for a while and says wait. And then once it's done waiting, you can click OK and you're ready to go. Now, the big key to doing this lab correctly or successfully is to making sure you are pulling with a constant velocity. We want to, when Jordan pulls this thing, we want to pull it with as close to a constant velocity as we can, because if we jerk it around, that'll change our acceleration, and we want to avoid that. We want to have a pretty consistent force of friction. And we'll see two forces. One is the force of static friction, which will happen when Jordan pulls it and the string tightens. That's why the string needs to be loose. And then the second one will be the kinetic friction force, which is while it is moving. So I'm going to go ahead and show what's happening, and then we'll take a look at the graph. So just like you normally would, you hit start, and then you go. So I'm going to go over to Jordan here. And there's my block. And there's the force detector. And again, you start pulling it when you hear the beeps. And there it goes, the string is tight, and there it stops, and you should see it retrieving the data. That was a nice gentle pull from Jordan. And, okay, we don't see much difference there in our peaks. You do see that there is a peak initially about right there, but then otherwise Jordan does a nice job of having pretty consistent motion. Now, if you find something like this and you decide, well, I don't really like that, I'd like to do it again, that's very easy to do. You can just set it up again, start it again. Now, if you get one that's good, which is a nice peak and then a pretty consistent area after that, you need two pieces of information. One is the force at that peak. So you want to pick about where the peak is, and then you can use your arrows. There you can see the force is 3.006. There's 3.179, so it's even higher. 3.105, so it looks like 3.179 is as high as I get, because now I'm going back down. So you can pick around until you find the highest point. That highest point, that's your peak static friction force. So that's one thing you need. Another thing you need is to find the average kinetic friction force. And to do that, you want to select your region. And the region you want to select is the area that's basically your constant force area. So that's pretty close. You can zoom in on that. And it doesn't look constant, but the force between 1.9 and 2.9, that's okay. We want to analyze this. And you can do it one of two ways, and probably the best way to do it is to do it as a stats. And there it tells you what your average kinetic friction force is. That's what the mean value is right there. That's kind of what you're looking for. So that would be the easiest way to do it. Use your mean then to find your average force. And you can see that that is less than what your static friction force was, meaning that it takes a little bit less for it to work. So there's your average kinetic friction force, and voila, we're done. And there we go back to our normal graph. We can click that. Oops, nope, don't want that. There we go. And now we're back to seeing what we saw at the beginning. That ends the first video about this. I'm going to have Jordan add some masses, and we'll see what the differences are between our graphs. There we go.